Okay, let's keep on talking about some other things real quick. Suppose that I want to spin this around along the y-axis. Well, you might think to use the quaternion right here, and specifically utilize this argument where we have a vector. And if you remember back to what I was just talking about, as we move the magnitude of this vector, it's going to spin things around. And I could say that by using the quaternion function and using $t in the y to basically pull that handle up over time. But the issue here, and you could see it more in the background, is that because we don't have a normalized vector, it's going to kind of freak out every now and then and spin really fast. So this isn't actually a great way of causing a general rotation to happen over time. Here's what I would do instead. So instead of using slurp, there's another function here that you can use to combine quaternions, and that's q multiply. It basically just multiplies two quaternions together and combines the result. But this in particular is much better because rather than trying to interpolate between quaternions, this is just going to blend between two quaternions. And so because of that, this will work out much better. Now, instead of using this way of doing a quaternion, let's actually specify an angle. So channel floats, let's create an angle here. We'll say this is our rotation angle. And then let's also create an axis to spin this on. So the y-axis, like that. Now, the q multiply needs two things. It needs the first quaternion, which is that, and the second quaternion, which is our tumble quarter. Now, here's a cool thing. I'm going to create that parameter here, this rotation angle, and set this to $t. Now, as you can see, over time, this q multiply is going to give us a much smoother result. It's going to blend this animation in a much better way. So as you are trying to blend animations, take a look at slurp if you want to go in between two quaternions, or you can use a q multiply to blend them together. Whatever tends to get you the better result, just go with that. So now, last but not least, if you want to create a 3x3 rotational matrix based off of what these blended quaternion rotations are doing, you can actually convert this back by using the qconvert function. Here's what that looks like. Let's say 3 at, so a 3x3 matrix, and we'll call this our rotation blend matrix is equal to qconvert, and then all you need to do is say at orient, and you're good to go. GeoSpreadsheets, rotation blend matrix, it's all right there. So there you go. That is the basics and the gist of quaternions, rotational matrices, and just in general, kind of what this stuff is and what it's about. Now, you'll see a lot of people use VOPs to achieve the same thing. In my opinion, it's well worth learning Vex and doing it this way because you'll see a lot better performance with just these few lines of code. And honestly, I think a lot of times it's also less prone to mistakes whenever you are working with fewer things. So yes, there are ways you can do this with VOPs, but if you can do this with Vex, I would say even better. Well, VOPs is Vex, but you know what I mean. If you can type it out, then it's much better. So anyway, I hope that you've enjoyed this quaternions rotations little mini course. If there are any topics that are related to this, which you'd like to see me cover a bit more, or you'd like to suggest, let me know about it. I'm very curious to hear what sort of stuff you guys find useful in production, and I'm more than happy to add additional things if it's a good contribution. Also, I want to let you know that if you're interested in following along with the submarine, I found that at CG Trader for $5. So I can't distribute this model to you guys because I didn't make the model, but you can go buy it for $5 if you want. That all being said, until next time, thanks for watching.